Okay, so in this question is related to a 1D constant acceleration kinematics problem, set in a context of sport of golf. So you're playing golf with your friends, you need to make this 6.25 meter putt to win the match. You hit the ball with the initial speed of 1.57 meters per second, but unfortunately comes up short of the hole. And the acceleration was constant, caused by the grass is constant. That's sort of the indication of the constant acceleration kinematics. What should the initial speed have been to just make the putt? So the first step is we have to figure out what is this constant acceleration caused by the grass. So I'll just set up a quick picture here. Problem. So you imagine this is the flag stick. So if I assume this is where the ball is, and I set this to x equals 0 meters, and the flag stick is 6.25 meters. So the ball ends up in after the first hit 1.4 meters short of the hole. So that's going to end up at a position of 4.84 meters, where this is 1.41 meters short of the hole. So that's just 6.25 minus 1.41 will lead us at 4.84 meters. So the ball travels initially delta x, xf minus xi is just going to be 4.84 meters minus 0 meters equals 4.84 meters. So that's how far the ball travels. And I'm assuming, I just made the assumption that it's traveling to the right. You could choose it traveling to the left initially. So if we want to figure out what is acceleration, we're not giving any time in this particular problem. So this makes me lean towards the VF squared formula. So I know that VF squared equals VI squared plus 2a delta x. In this situation, I know that when the ball travels 4.84 meters, the VF is 0, comes to rest. It's given an initial speed of 1.57 meters per second, and the delta x in this case, when it does come to rest, is 4.84 meters. So we can try to solve for the acceleration. So I can see here that if I rearrange this equation, a will be equal to VF squared minus VI squared over 2 delta x. So that will be equal to the 0 squared minus 1.57 meters per second, all to be squared, divided by 2 times that initial distance. And that gives me an acceleration of negative 0.25 meter per second squared. So now that we know the acceleration, it will be possible to solve for the initial speed of the putt in order to go 6.25 meters with an acceleration of this amount. And again, to just make the putt, that means that the final velocity is essentially 0. So the ball just falls, just comes to rest at the hole, so it just falls in. I'm going to assume that the final speed is again 0. So in this expression, for the second part of the problem, I'm just going to try to solve for VI, knowing what the A is and knowing what delta x is. It's going to be 6.25, and assuming the final speed is 0. So my initial speed that I'm trying to solve for is going to be equal to this negative 2a delta x. So VI will be equal to the square root of negative 2 times a times delta x. So I'll just move down here slightly. So VI will be square root of negative 2 times negative 0.25 times the entire distance this time, and that VI would have to have been 1.78 meters per second. So if they give the putt initially this speed, that's enough to make it travel 6.25 meters with a constant acceleration of negative 0.25 meters per second squared. So give it a check. choice C is the correct answer.